All right, here is Chapter 8, Learning Target 1. We're going to start to solve some trig equations. We're not going to get to any applications today, but we're just going to practice on how we solve them. And we're going to start with a question here that really could have been a test question from Chapter 7. If sine of theta is negative square root 3 over 2, what is theta? What angle are we talking about? In Chapter 7, we talked about how we would reference 2 points in the unit circle and look for their y-coordinate to verify which one has a sine value of square root 3 over 2, or negative square root 3 over 2. Now I'm just going to cut to the chase here, and you could certainly go to a unit circle to verify these, but there's 2 points on the unit circle where the y-coordinate is negative square root 3 over 2. It's 240 degrees and 300 degrees. Okay, and those are the solutions for theta for the unit circle. So any value of theta that's from 0 to 360 degrees. Okay? Well, same question here, except now we're dealing with a sine value that's not on the unit circle. Okay, and what we want to look at today is how do we handle that case? Sine of theta is 0.1234. Okay, now there's 2 solutions here. And to get the first one, I will simply take sine inverse of 0.1234. I need to use my calculator because this is not a key point on the unit circle. And I get 7.09 degrees. A small angle right here in quadrant 1. Okay, and if I thought about this as a point on the unit circle, it would be the point that has some x-coordinate. I'm not exactly sure what it is, but I know that its y-coordinate would be 0.1234. Now that's fine. It seems pretty straightforward. We just use the inverse feature on the calculator to get that angle. Thing is, there's another solution. Just like the 240 and the 300, from 0 to 360 degrees, there's another. Well, it's over here. Okay? There's another point that has the opposite x-coordinate, but its y-coordinate is still 0.1234. And its reference angle to do that would have to also be 7.09 degrees. So my second solution would come from take 180 minus 7.09 degrees, and we would get 172.91. degrees. Okay? And those would be our 2 solutions. Now, if we wanted to generalize this pattern, it would be that we use the calculator to get the first solution, and then if we take 180 minus our first solution, that will give us our second. So let's just generalize that pattern. Okay? In degree form, if we get a solution to a trig equation involving sine, okay, we just do 180 minus our answer, and that'll give us the next solution. Okay? For example here, if sine of theta is 0.34, I would start on my calculator and just do the inverse. And I would get that theta is 25.5 degrees. Okay? Now there's another solution which I can get. That's what this rule is telling me. If I do 180 degrees minus the first solution I got, that gives me that second solution. Okay, if I'm in radian form, the only difference is instead of subtracting from 180 degrees, I would subtract from pi. Okay? try this next one here. Sine of theta is negative 0.8. This one turns out to be a little bit different. I take the inverse, and I get that theta is negative 53.1 degrees. Now that's fine. Everything seems to be good and well, except this said to solve it from 0 to 360, that angle is not between 0 and 360. Okay, it's less than 0. One thing I can do here is just take a really straightforward approach. Let's get a coterminal by adding 360, and I end up getting 306.9 degrees. Now it's a coterminal because I added 360, so its sine value is still negative 0.8. Now it's just in the interval that I'm looking for. Okay, so that is one of the solutions. All right. Now how do I get the other? Okay, if I took 180 minus 306.9, once again, I will leave the prescribed interval. That'll give me negative 126.9 degrees. That's not between 0 and 360. To get the other, I can actually use that initial answer that I got of negative 53.1 and then follow the same rule. Subtract that original answer from 180 degrees, and I get 233.1, and that is in the interval. So 306.9 and 233.1. All right, the next two examples are, you would do them exactly the same. It's just that those are in radians. You're going to do those in radians instead of degrees. Okay, so get your first solution from your calculator. Make sure you're in radian mode. And then subtract the first one from pi. All right, so cosine and tangent have slightly different rules because they're slightly different trig functions. But for the very same reason that there's this little pattern that we saw with sine, that if we subtract the first solution from 180 degrees, we get the second. Cosine is similar, except in degrees we have to subtract it from 360, and in radians we subtract it from 2 pi. Tangent, we add the first solution to 180 if we're in degrees, or add the first solution to pi. Let's go take a look at some examples. Now these ones look a little bit different, but don't get too thrown off by these. If we have something like 3 cosine of theta, we want to get it in the form that we had before, where the trig function is all by itself. Okay, all by itself. So I get cosine of 1/3. This is where I would go to my calculator and do second cosine of 1/3. I get 70.5 degrees. And then to get solution number 2, I'm going to take 70.5 and subtract it from 360, just like the rule said. And 360 minus 70.5 would be 289.5. Same process with cosine, just a slightly different rule, that I have to subtract the first solution from 360. Okay? Here's an example with cotangent. I have a little work to do here. I want to get this solved, so cotangent is all by itself. I will first add 3 to both sides, then divide by 4. Then I get that cotangent is 3/4. Now, this is the point where we said go to your calculator and do the inverse. Well, the issue here is that there is no inverse button for cotangent. We just have an inverse feature for sine, cosine, and tangent. Not a big deal. if we use a reciprocal function, we could switch this to tangent because there is an inverse tangent button, as long as we flip that ratio from 3/4 over to 4/3. Okay. Now I could do the inverse of tangent using 4/3. And I get 53.1 degrees. And the rule for tangent said to take that first solution and add it to 180 degrees, which would give me 233.1. Okay. And down here, we're going to switch to radian mode. All right. And again, we're dealing with reciprocal function. I just want to show you that these are not terrible cases, and we can handle these just fine. Okay. Secant immediately needs to be changed to cosine. That's its reciprocal function. Now this is really secant of 2.5 over 1. So I would just flip that and switch it to cosine of x is 1 over 2.5, which would be cosine of x is 0.4. And as I've done for every example, I would then go to my calculator and use the inverse. And I'm in radian mode now, so I get 1.16 radians. And then to get my second solution, because it's cosine, I would take 2 pi minus 1.16. I'm using 2 pi here instead of 360 again because I'm in radians. And I would get 1.52 radians for my two solutions. Okay. Let's take a look at just one more. I have cosecant here, so I want to get that all by itself. Subtracting 3 gives me negative cosecant of x equals 4. And dividing by 1 gives me cosecant equals negative 4. Here's where I will use a reciprocal. I want to switch this over to sine, because now I can use my calculator with sine, so long as I take the trig value and flip it. Okay. Now let's actually work this one all the way through. I can use my calculator and take inverse sine of negative 1/4. Now remember, last time I took the inverse of a negative sine value, things got a little bit weird. And I'm expecting they're going to here as well. And sure enough, they do. I get negative 0.25 radians, which I don't want. Okay, it says my answers need to be between 0 and 2 pi. And just like the one before, I just need to think in terms of a coterminal. Okay? If I take negative 0.25 and I add 2 pi, I'm still in the exact same position on the unit circle. But now I have an angle. Remember, 2 pi is about 6.28. 6.03 is in the interval that I'm looking for. That is solution number 1, 6.03 radians. Okay? And now to get number 2, for sine, I subtracted from pi. But when I subtract, now I can go back and take the original solution that I got. As this gives me an angle that is still between 0 and 2 pi. Solution number 1, solution number 2. Okay? That'll be all for 8.1. Again, the theme here was solving some really basic trig equations. This is something we're going to do a lot more in Chapter 8. So make note of any questions that you had and be sure to talk to me more about those, because it's important that we get comfortable using the inverse, because we're going to do it a lot in Chapter 8.